Welcome everybody to Algebra 1, Section 2.5, Infinitely Many Solutions, No Solutions, and Proportions. So let's first talk about no solutions or identity problems, which are also our infinitely many solutions problems. Some equations may have no solution. This means that there's no value of the variable that will result in a true equation, while other equations are true for all values of the variable. So no matter what you plug in, it'll always work. And an equation like this is called an identity. So let's practice one of each of these. And you'll notice each of these look just like a normal algebra equation. And at first they are like that. And so we solve in all the same ways where we'd start by distributing this -4, getting -8x minus 4, and the right hand side stays the same. Then as I look to move one of my x's, we notice that they're the same. And so if I add 8x to either side, they both eliminate. Now, a tendency for people here, because they're like, well, we need a variable is the thought, is they'll put x. However, that really means 1x, and there's not 1x, there's 0 x's. And 0 x's means there's no x's at all, and we don't need to put 0 minus 4, we can just put the -4. And the same thing if it was on this side, for example, as well. It's no x's, you don't put x, you don't put anything there for variables. Now, when we do get an equation with no variables like we have here, we have to say, all right, to determine is it true or is it false? And in this case, it's false. -4 does not equal -2. And so I'm going to write that it's no solution, which I can abbreviate as the following. Now, this means, once again, that no matter what you were to plug in, it would never, ever, ever work, no matter what. Infinitely many solutions or infinite solution just means that no matter what you plug in, will always work, and we'll see that here. So -5 minus 9x, and then we distribute the 3, and we get 3 minus 9x minus 8. Then we combine like terms on the right-hand side, and I get -5 minus 9x equals -5 minus 9x. Then we add 9x to each side. The x's eliminate, and I get -5 equals -5. Now, no variables, we ask ourselves, is it true or false? This is true. So because it's a true statement with no variables, we say it's infinitely many solutions, which we can abbreviate to IMS. You also might hear it called all real numbers, which means the exact same thing. It just means all real numbers would work. Or you could abbreviate that to ARN. And they all just mean the same exact thing. So whether you write infinitely many solutions, IMS, all real numbers, or ARN, it does not matter. No matter what, it just means no matter what was plugged into x, it would always, 100% of the time, work out to be true. So let's practice solving some of these problems. And so here on this first one, we'll distribute 8, we get 40c minus 16. On the right-hand side, we distribute 10, we get 320 equals 40, assuming plus 40c. Subtracting 40c from both sides, we have no c's left, so we get -16 equals 320. No variables, so we determine that this is either true or false, and this is false. -16 is not equal to 320, and so it's no solution. On the next one here, we distribute the 4, and we get 4t plus 80 equals 1/5 times 20t, or 1/5 of 20t. Since it's a 1 on top, we can think of it as just dividing by 5, and so we get 4t plus 80. Now, you might notice here that these are the exact same things on each side, and because it's the exact same thing on each side, I can already tell you it's going to be infinitely many solutions. And if we continue on, we'll see this is the case. Subtracting 4t, we end up getting 80 equals 80. That is true. And so it is infinitely many solutions. No variables, true statement. And the reason I knew that up above was, once again, the exact same things are on the left and right side. No differences at all. Not even a sign is different. Now let's practice some more examples, and these are going to have some regular problems mixed in, because the thing is you won't necessarily know if you have an infinitely many solutions or no solution, or just a regular problem as you work through them. So number 1 here, we multiply the 3 and we get 6x plus 6 minus 3x equals 6 plus 3x. Combining like terms on the left gives us 3x plus 6 equals 6 plus 3x. These are the exact same things on each side, a 3x and a 6, and they're both positive, and so it will be IMS, but I'll show the next step anyway. We subtract 3x from each side, and we end up getting 6 equals 6. No variables, and it is true. Number 2 here, we distribute the 6 on the left, and we get 12x minus 36. On the right, we distribute negative 7 and get positive 14x minus 28. Subtract the smaller variable, and we get minus 12x. And we get negative 36 equals 2x minus 28. Add 28 to both sides. And we get negative 8 equals 2x. Dividing by 2 results in x equaling negative 4. So this was a normal problem, no special case such as an IMS or infinitely many solution. Now, one way you could tell partway through the problem here in the purple that is going to be a normal problem is that the sides were completely different. The x's were not the same at all. If the x's are the same, it's one of the scenarios. After you combine like terms, it's one of either IMS or infinitely many solutions. We just have to figure out which one's which. Number 3 here, distribute the 8, and we get 40x minus 24. On the right-hand side, distribute the 6, and we get negative 18x minus 24. Now, these numbers are the same, but that's not the same thing as the variables being the same. So we still add 18x, and I get 58x minus 24 equals negative 24. I add 24 to both sides, and I get 58x equals 0. Now, some people just get to this point and they say, oh, IMS or no solution. However, that's not the case. That's only the case if that is one of those two if you have no variables left. We still have variables, and we treat 0 just like we would any other number. So if we had any other number on this side, such as 5 or whatever, we would divide by 58. And so we're going to do the exact same thing and divide by 58. And x equals 0 divided by any other number, which is 0. And that's the number. Moving on to number 4 here, the left-hand side just remains the same. There's nothing you can do. On the right-hand side, we distribute 7, and we get 7x plus 14. Distribute the negative 4, and we get negative 4x plus 28. Combine like terms on the right-hand side, and we end up getting 3x plus 42. Subtract 3x from each side. Those eliminate, and you get negative 13 equals 42. Add 13 to both sides. Oh, wait, actually no variables. So we say, is this true or false? It is false. And so there's no solution. And because they were the same variable on each side after we combined every like term, then we notice that it's either going to be IMS or no solution. In this case, it was no solution because the numbers were different. Now let's talk about algebraic proportions. So algebraic proportion is when you have fractions equal to each other. So the fractions are being compared. And so we're going to see two fractions equal to each other on all of these problems. And so some steps to solve. Well, step 1 is to cross multiply. And cross multiplying is when you have a fraction such as a over b equals c over d. And what you do is you multiply diagonally. So you do a times d, and you do c times b, or bc, and you set those two things equal to each other. And it doesn't matter whether you put this diagonal on the left of the equal sign or the right of the equal sign, because if you do flip them, it's the exact same thing anyway. So you multiply diagonally and set those two side diagonals equal to each other. Then step 2 is to distribute if necessary. That's part of the cross multiplication. And then last but not least is to solve using our normal solving methods at that point. So at that point, it'll turn into a normal problem, and so we solve using our previously used methods. So on number 1, we have two fractions equal to each other, so we're going to cross multiply. So I do one diagonal, 4 times 6, and I get 24. I set that equal to the other diagonal, 3 times x, which is 3x. There's no distributing needed. In that cross multiplication, I'll explain when it will be needed, such as in example 2. And so I just solve using my normal methods where I divide by 3. and I get x equals 8. And if we were to plug that back in, it would be true. 4 over 6 would be equal to 8 over 6. Sorry, 4 over 3 would be equal to 8 over 6, because 8 over 6 reduces to 4/3. Number 2 here, we have 2 over 10 equals 4 over n plus 5. And so we have two fractions equal to each other, so we cross multiply. Diagonally, we have 2 times n plus 5. So this is where the distributing comes into play. It's part of the cross multiplication. We have to take 2 not just times n, not just times 5, but times both, or the whole thing. So 2 times n is 2n, and 2 times 5 is a positive 10, and then we set that equal to the other diagonal. So that's what that means by distributing, is you have to multiply one diagonal times the entire other diagonal. 10 times 4 is 40. Now we solve using our normal two-step equation methods, where we subtract 10 from both sides, and I get 2n equals 30. Divide both sides by 2. Let me rewrite my 0 for the 30. And I get n equals 15. On number 3 here, we have two fractions equal to each other, so once again we cross multiply. We have to distribute to the entire top left here, so 5 times y is 5y. 5 times negative 3 is negative 15. Diagonally the other way, 2 times y is 2y. So I can either move my 2y from right to left, which I normally would do since it's smaller. However, since my numbers are already on the left, I'm going to move my variables to the right in this case by subtracting 5y. That way my numbers and variables are on opposite sides. Negative 15 equals negative 3y. And I'm going to divide by negative 3. And get y equals 5. You could have still gotten the same answer by subtracting 2y to begin with, but you just have to move your 15 to the other side after that. Number 4 here, two fractions equal to each other again, so once again we cross multiply. 5 times the entire numerator, 2k plus 3, so 5 times 2k is 10k, and 5 times negative 3 is negative 15. On the other diagonal, 3 times the entire denominator, 3 times k is 3k, and 3 times positive 9 is positive 27. So now we continue solving from here. I'm going to move by a smaller variable, which is 3k, by subtracting it. And I get 7k minus 15 equals 27. Now I'm going to add 15 to both sides, move those away from my variables. And I get 7k equals 42. From there, I'm going to divide by 7 and get k equals 6. That's my answer. Let's do some more practice problems, because, why not? Feel free to work ahead on any of these and to pause the video and go ahead and compare it to see how you did from how I did. So diagonally here, 3 times the entire numerator gives us 3x plus 30. The other diagonal gives us 8x. I'm going to subtract 3x from each side to get 30 equals 5x. Dividing by 5 gets us the answer as 6 equals x. Number 2 here, diagonally, 6 times p plus 2 gives us 6p plus 12. 3 times p plus 7 gives us 3p plus 21. I'm going to move my smaller p to my other side, which is subtracting 3p. 3p plus 12 equals 21. Subtract 12 from each side, and I get 3p equals 9. Then I'm going to divide both sides by 3, and p equals 3. Next, diagonally, on number 3, 6 times w minus 2 gives us 6w minus 12. The other diagonal, w times 3 is 3w. Set those equal to each other. I'm going to move the 6w to the right since already that will get it away from the numbers, and I'll get numbers on the opposite sides of the variable. So I get negative 12 equals negative 3w. Divide by negative 3. And 4 equals w. On number 4, diagonally here, n minus 4 is going to multiply with 9 to get 9n minus 36. The other diagonal, 6 times n minus 7, gives us 6n minus 42. Now these are equal to each other, so I move my smaller variable by subtracting 6n. I get 3n minus 36 equals negative 42. Adding 36 to both sides, I get 3n equals negative 6. Divided by 3, n equals negative 2. Moving on to number 5 here, diagonally I multiply again. 3 times the entire denominator, a plus 1 is 3 plus 3, or 3a plus 3. 2 times the other times the numerator, a minus 3, gives me 2a minus 6. I'm going to move my smaller variable by subtracting 2a. I get a plus 3 equals negative 6. Subtracting 3, a equals negative 9. Number 6, diagonally, 3 times 25 gets 75. 5 times the entire denominator, f plus 2, is 5f plus 10. I'm going to subtract 10 to move my numbers to one side, and I get 65 equals 5f. So they're on opposite sides, so I can go ahead and divide by 5. And by they, I mean the numbers and the variables. And I end up getting 13 equals f. Example 7 here, diagonally, 8 times m minus 8 gives us 8m minus 64. The other diagonal gives us 6m minus 54. I'm going to subtract 6m from both sides and get 2m minus 64 equals negative 54. Adding 64 to both sides results in 2m equals 10. Divided by 2, and m equals 5. Number 8 here, diagonally, 2 times r is 2r, and 4 times r plus 4, it gives us 4r plus 16. Subtract 4r from both sides, and we get negative 2r equals 16. Once again, I moved the bigger variable at that time to move it away from the numbers since the numbers are all on one side. Saving myself a step. I'm going to go ahead and divide by negative 2. R equals negative 8. Number 9 here, diagonally 5 times v minus 2 is 5v minus 10. The other diagonal, 2 times v minus 8 is 2v minus 16. Subtracting 2v from both sides, my smaller variable, I get 3v minus 10 equals negative 16. Adding 10 to both sides, I get 3v equals negative 6. And now dividing both sides by 3 to undo the multiplication gives me v equals negative 2. Last one on this page, number 10. 6 times the diagonal of k minus 6 gives us 6k minus 36. The other diagonal, 8 times k minus 1, is 8k minus 8. Subtract 6k from both sides. Negative 36 equals 2k minus 8. Add 8 to both sides. Negative 28 equals 2k. Dividing by 2. And k equals negative 14. Moving on to our last 6 examples on the next page. Number 11 here, 4 times the diagonal of y minus 7 gives me 4y minus 28. The other diagonal, 3 times y minus 9 is 3y minus 27. So moving my smaller y, I get y minus 28 equals negative 27. I add 28 to both sides, and I get my answer, y equals 1. Number 12, diagonally, h minus 6 multiplies with 4, it gets us 4h minus 24. The other diagonal results in 9h plus 81. I'm going to go ahead and subtract 4h from both sides and get negative 24 equals 5h plus 81. Then I'm going to subtract 81 from both sides and get negative 105 equals 5h. divided by 5, and h equals negative 21. Number 13, diagonally r times 4 is 4r. And the other diagonal gives us 2r plus 20. We're going to subtract 2r from both sides, and I get 2r equals 20. Divide by 2 on both sides, and I get r equals 10. Number 14, diagonally 7 times x minus 6 is 7x minus 42. The other diagonal gives us 6x minus 24. From there, I'm going to subtract 6x from both sides and get x minus 42 equals negative 24. Adding 42 to both sides, I get x equal 18. Number 15 here, 2 times 4u plus 9 rather, is 8u plus 18. And the other diagonal, 3u plus 7 times 3 is 9u plus 21. Subtracting 8u from both sides, the smaller of the variables, I get 18 equals u plus 21. Subtracting 21, I get negative 3 equals u as my answer. Last but not least here, number 16, one diagonal from 2x minus 1 times 10 would be 20x minus 10. The other diagonal gives us 15x plus 5. Subtracting 15x from both sides, 5x minus 10 equals 5. Adding 10 to both sides, 5x equals 15. And dividing by 5, x equals 3. And that wraps up Algebra 1, Section 2.5.